Hello everyone, today we'll start with my assignment 3. So task 1 is data loading. We're asked to load the NYC taxi data for the set of month on January, March and June. So I've already downloaded the datas, okay, and it's read the parquet file, okay. Then finally I print the info in the head, so info tells you the columns as well as the data type for each of the columns as well, while head prints out a sample of how the data looks like. For example, in January data sample, you can see vendor ID, pickup date time, and such. Okay. So this is my explanation for all the columns, which is gotten from the data dictionary. So number 2, compare the 3 months of data and identify and discuss 3 different trends. The first trend I've chosen is to compare the passenger counts between all 3 months. And for this, it's quite simple. I created a function to investigate the average passenger count. Basically, it gets the mean and print them out. As you can see, it's rather similar. June is slightly higher than January and March, but it's very similar for all 3 months. Trend 2 is to compare the most common payment type for each month. So first of all, since they saved integer from 1 to 6, I actually created a small mapping tool for 1 to be credit card, 2 to be cash, etc. Then I created a small function called most common payment type, where I just get the mode and basically for each month and print them out. As you can see, credit cards it's the same for all 3 months. As such, we can see that the month does not affect the payment type. Finally, trend 3 is to compare the average trip distance for all 3 months. Similar to this, I created a function called compare average trip distance, which get the means for all the months. As you can see, interestingly, in June has the most miles, which is 4.37, followed by March and January. So the reason why I said there was a difference in this time around, because January is still winter, March is spring, and June is summer. So perhaps during summer, hotter months, people want to go and travel to beaches or seasonal events, while in January, while it's winter, people tend to travel not too far away because it's too cold perhaps. Alright, so task 2 is data exploration and preprocessing. So first we check the missing values by using the isNull function and get the sum of it, and we print it out. As you can see, few columns are passenger count, rate code ID, store, and this column has null values, and we actually drop the null. That's how we're going to solve this is how we're going to preprocess our missing values. We're going to drop the null. Alright, so the reason why I do this is because it's a straightforward approach, and normally the other approach would be replacing the null values with dummy values, which I feel might compromise the integrity of the dataset. Right, second, identify the 2 columns with noisy values. So the 2 columns I've chosen are actually passenger count and trip distance. Passenger count because it is based on the data dictionary. It is a field which is inputted manually by the drivers. As such, it's very prone to human error. And when we do check it, we do realize that there is a lot of noisy errors, in the sense that anything below 1 or above 6 is what we consider as noisy. Below 1 means that there's no passengers there. Below 6, well, most rides sharing only have 6, like Uber XL. So anything above 6 is false. As you can see, around 51,184 of them passenger counts have fit this criteria. We also choose trip distance as our second noisy value, and the filter we had for this time around was less than 0 or more than 302.6. Less than 0 meaning the trip went nowhere, while more than 302.6 is unlikely because the size of New York City is around 302.6 miles. So yeah, anything above that would be wrong. As you can see, there's around 38,000 noisy values in trip distance. Alright, third question. Identify 2 columns that are highly correlated. Explain the correlation. So we use the CORR function, get the correlation matrix. We created a simple code which kind of returns back the pairs of which have higher correlation than 0.7, which 0.7 is normally accepted as high correlation. And there's 3 of them. I chose to talk about the heights of them, total amount and fair amount. The reason why it's highly correlated because the total amount mostly is the fair amount. Anything extra would either be the small fees such as tips or surcharge or tolls. So at such total amount and fair amount would have naturally high correlation due to the fact that they're almost similar, while total amount is normally a slightly bit extra than fair amount. So task 3 is visualization. First, we're asked to create a feature which is a flag indicating if the trip is in rush hour or not. So I provided a plot which kind of shows the peak travel hours, and from that plot I found out that the peak travel hours are normally from 2 p.m. to 7 p.m. So as such, I create a new column called rush hour, and it basically checks that, oh, if this trip happened during that time, mark it as rush hour. All right. For number 2, we were asked to create a feature that encodes the complexity. Unfortunately for this, I couldn't get this to work. I installed many packages, I tried running it, and I couldn't make it to work. So I deleted my code because I didn't want an incomplete and unrunning code in the final assessment. But yeah, for this one, I couldn't manage to get the feature out. Finally, for third one, we calculate the pickup and drop-off frequency of each taxi zone. So what we have done is we load the new file, this taxi zone lookup. All right. Then we group up the locations and based on the location IZ for both the pickup and drop-off and calculate the frequency. Then fill up any values with 0 for anything that has no pickups. And then we just display the resulting data frame, merging the old data set with the new data set that we just loaded in. And this is what we get. Alright. Task 4, data analysis. So rank the vendors by popularity. Quite simple. For this one, we just sort them and sort them by ascending false, which means that highest be first, and as you can see, vendor 2 is most with 219,000, while vendor 1 only is 8,000. Vendor 2 being Verifone Incorporated, vendor 1 being Creative Mobile Technologies. Second, what are peak travel hours? So this is the plot I was talking about. Basically, I converted the pickup hour to daytime, calculate the frequency, and just plot them up. As you can see, this is a plot. And if you notice, from 2 p.m. to 7 p.m. has the highest peak. Before that, it's dropping, and after 7 it drops intensively as well. So as such, I've chosen 2 to 7 p.m. but of course it's up to you to depend how big you want that rush or peak hour to be. Third is what's the average distance of trips traveled on weekend and weekdays. So for this one, simple, I counted daytime as well, and I change it from 0 to 6, 0 being Monday, 6 being Sunday. So if it's 0 to 4, I categorize it as a weekday, and it's 5 to 6, I categorize it as a weekend. Then I edit the dataset, the new column of weekend or weekdays. And finally, I just calculate the mean for both of them. As you can see, the average trip distance of weekend is slightly more than the weekdays. Next is what is the average number of passengers in the trip of weekdays and weekends. Similarly, I use the new category of day category, calculate the mean and print them out. As you can see, normally in weekends we have a slightly higher average passenger compared to weekdays, so 1.45 to 1.33. Next, what's the correlation between the fare and the tip? And what we can do, we get the correlation for both of the pairs. As you can see, it's 0.59, which is moderately high. It's not high, but moderately high, which do indicates that a trip with higher fare amount normally tips higher as well. And next is what is the correlation between the fare amount and number of passengers? Same thing, get the correlation of the same pairs. For this time, it's 0.03, which is very little, almost non-existent. And as such, we can conclude that having higher amount of passengers doesn't necessarily mean that the tip will be higher. Now the task 5 conclusion. Summarize key finding. I actually went through all the key findings in this thing as well, but I've written it here in a more concise version and reflect any challenges that you may face. From here, I mostly talk about task 3, which was the featureization, and how I actually failed to make task 3 question 2, creating the complexity feature. So that was the biggest challenge I faced during this analysis. And finally, for suggesting possible next steps or additional analysis that could be performed, I actually thought about what we can do is start forecasting and predictive analysis, because that's what data science is all about, right? So one of the things I thought is that, it's good if we can find areas which have peak hours, peak demands, and assign drivers based on the demands. If this area is known to have, for example, area 1 is known to have a peak hour at, let's say, 3 p.m., then assign more drivers there by giving them either additional incentives. Furthermore, I felt that data collection would be better. We should either remove any manual data collection as well as add in stuff like weather, because weather affects a lot. For example, if it's raining, when it's raining, will there be more trips, will there be less trips, or is there surcharge and such? So yeah, I think the additional analysis that can be done mostly includes predictive analysis. And that'll be all. Thank you so much. Take care.